Hi everybody, Brian Sather here from the simulation team at Autodesk. Now I'm pretty excited to show you a brand new simulation technology that comes with Autodesk Mold Flow Advisor 2012. And trust me when I tell you, this is going to change how you use simulation during the design of your plastic parts. So first notice that we're not in the Advisor UI. This new technology is actually a CAD plugin for both Inventor and Pro Engineer. We'll first start by pulling up the fill preview. Now I know what you're thinking, right? This isn't really anything new. We've been able to see the filling pattern in Inventor for the past couple of years. Well, let's say I want to add a complex pattern of ribs to this part. This is where it gets good. The plugin recalculates instantaneously and we can see the updated filling pattern. That is definitely something new. So go ahead and take a second to think about how this might change how you use simulation. No longer is simulation going to be an afterthought, something you use after the design is done. It's now an integrated, concurrent part of the design process. So I'm going to go ahead and switch to something a little bit more complex so we can show off the rest of what this thing can do. Now the first indicator down here is all about manufacturability. It's helping you answer the question, can I even mold this thing? So let's first take a look at wall thickness. It's one of the basic design rules, but also one of the most important decisions you have to make early in the design. Now an alert will show up if your part is too thick, too thin, or if there's just a lot of variance. Or you can just pull up the wall thickness diagnostic plot anytime to take a look. Next up is undercuts. This time there's an alert saying there's areas of the part that will be difficult to eject without some kind of complex tooling, which is pretty much the definition of an undercut. Now all we have to do is click the alert and it brings up the diagnostic showing everywhere there's an undercut feature on the part. Now the last of the design rule checks is for draft angle. So again, there's an alert saying that there are a few surfaces that are not drafted properly. When we click it, the diagnostic comes up showing everywhere we forgot to draft. It's pretty handy. But remember, I'm showing all of this after the fact. But in use, the plugin recalculates every time the design is modified. So as soon as you forget, as soon as you make an error or violate a design rule, intentionally or unintentionally, you're going to know about it. Okay, so the next thing I want to talk about is weld lines. Now these are available because we're doing the real-time fill analysis, so the alert gives you the option to pull up the animation and the injection location toolbars. Now the best part about this is we can actually play with different gating configurations so that we get the best placement of the weld line. That's pretty cool, right? Now also thanks to the fill preview, we can predict sink marks. Now the plot itself is nice, but to really understand how bad they are, let's use the finished part preview. Now with this, you can get a better idea of the location and the relative visibility of the sink marks on the part. It also shows weld lines with little red dots. So, all of this is very important information to have when aesthetics of your part are critical. Now the last thing for manufacturability that we have is you can actually see the injection pressure that's required to fill the part. And again, you can move this injection location around so you can play with different scenarios to see the effects that has on how much pressure is going to be required. And if all that wasn't enough, there's still two more indicators that we haven't touched yet. So for cost, we have three factors. Mold cost is influenced by the overall size of the part as well as the complexity. So for example, the more undercut features it detects, the higher the cost is going to be. Now material cost is a relative indicator based on the material you've selected to mold this part off. The default is going to be always ABS, but that can be changed in the iProperties dialog. And then finally, the production cost is completely based on cycle time. And of course, the biggest factor usually in cycle time is the cooling time. So things like making the part thinner will help to reduce that cycle time and reduce that cost. Now the last indicator, but certainly not least, is the plastic material impact. So with this one, there's actually four factors at play. And the first of which is the carbon footprint. Now the carbon footprint does a calculation as to how many kilograms of CO2 are produced when you actually have to make the raw material needed to mold this part. And to show you how much impact that decision about which material you use is going to have, let's go ahead and change this just for the sake of argument to polycarbonate. Now the result of this decision is an additional kilogram of CO2 for every single part you make. That's good information to know, right? Now, the next one is embodied energy, and what this does is it calculates the amount of energy required to manufacture the part. Most of this is impacted by the material you've selected. Recyclability is a relative indication as to how well this plastic, either as scrap or at the end of life, can be reprocessed into something useful again.
And finally, embodied water calculates how much water is required to manufacture the part. Similar to what we did with the energy calculation, a lot of this is due to the raw material production itself. So to wrap all this up, Advisor Design does a lot of cool stuff, right? But the fact that you can now do simulation completely in line with the design is a huge improvement to the overall workflow. And hopefully it's going to result in a lot higher quality parts and a lot less time.
So thanks a lot, and remember, if you are a Autodesk Moldflow Advisor subscription customer, you can download this right now from subscription.autodesk.com.